Hello there, math fans. This is going to be a supplement for my Math 112 business math students primarily, but might be helpful to other students about functional notation. The first homework set has quite a bit of functional notation because it's a course getting us ready to do a little bit of calculus, and I find that a lot of students struggle with that. So in this video, I'm going to do a few things. Review functional notation. I'm going to talk about your approach to these problems. I'm going to show you an old exam question that's identical that students missed, and I'll show you some of the errors they made in hopes that you don't make them. But before I do that, I want to give some motivation because it's going to feel like pushing a lot of symbols. Functional notation is very valuable for giving a general process for studying something. So I just thought I would make up a quick example. So imagine I throw this ball up in the air really, really hard, or I fire it in the air or something. It goes up, it comes down, and I would like to study things like what was the highest it ever got? How fast did I fire it? How fast is it when it's coming down? Turns out the formula for that is, in terms of time, looks like this. Now, I remember being confused by this as a student. So the x-axis is time. And when we go, the first time I ever saw this, I was confused as a student. I was like, hold on. I thought the ball was going straight up and straight down. It is. We're just drawing it this way so we can easily see the time. Here's where it is at 4 seconds. Here's the height at 5 seconds. So it takes 5 seconds to hit the ground again. But what we'd like to do is study velocities in order to find when we're at the top. What we want is the location when the slope is 0 or the velocity is 0. In order to figure that out, we have to figure out what the slope is. In order to know the slope, we have to know some functional notation. So that's what it boils down to is, ultimately we're going to use 2 points. This is a fundamental piece of calculus that we'll talk about. But we're going to find the slope of that red dotted line, and then we're going to ask ourselves what happens when the red dotted, the second point gets closer and closer. And that's how we find the slope of the tangent. But that requires we understand what f of x is, what f of x plus h is. That's where the functional notation comes into play. Once we do it, then we learn a bunch of shortcuts. But it does require we can understand and not be thrown off by these things. And over the years, it doesn't matter whether it's my business math class or my regular calculus class, I find some students just can't seem to handle this. They're given this and asked to do this, and they're just blown out of the water. And I don't want you to feel that way. Okay, so how do functions work? What happens is you have a formula. Maybe it's the height of that ball. Just very briefly, I'll go through this. Someone's giving you some formula. Here, I'll say it's the height. I won't even put an equal sign. Let's just call this thing. Whatever comes out of this is the height of the ball. We'll say that x is time. And I did try to use somewhat realistic numbers. This would be seconds. This would be meters. But you don't need to know that for this course. We would like to do some stuff with it. We'd like to plug numbers into it. We would like to work with it. And so we'd like to give it a name, just so we can refer to it. And whenever we want to plug something into it, we will call on that function. We'll call its name out. Now, the name could be anything. We could have the name be Fred. And so there's an extra piece that confuses people. But if I want to know what Fred at x equals 3 is, what they're asking me to do is to plug in 3. Now, when we plug in a number, there's an order of operations thing. This only applies to the thing we're plugging in. It doesn't apply to the 10, or else they would have put the 10 in parentheses. And so it's a good policy, if you're not good with your order of operations, to put parentheses every time you plug something in. If you know your order of operations, it's not a big deal, but I do see mistakes on that. So this would be negative 10 times 9 plus 150, so this is 60 meters. So Fred at 3 is 60. And we do that a lot where we're plugging things in. So at some point somebody said it'd be nice if we had a notation, a subscript, I don't know. Somebody said, well, let's just put parentheses there. And I think that was maybe a poor choice. I don't know what else they would have done, but it's very standard. So you have the name, and then you have a reference to what we're plugging in. All of this is a single unit. You don't distribute, you don't mess around with that at all. It's just a name. And this equal sign is actually a definition. It's giving a name. We're just giving a definition of the form. So it's not something we're solving. I have just seen over the years a lot of students try to solve this. Many times I've seen this. They distribute the f. That doesn't make sense. It's one unit. This is indivisible. It's just a name. Okay. So let's get into it a little bit. So let's, instead of calling it Fred, let's use kind of the more typical, let's call it f of x. So again, that's just a name, definition, and we would write f of 3 is this. Okay, so that's the basics of functional notation. At some point, we always lose people, though. If I want to plug something else in, let's say I want to plug in 3 plus 1. 1 second after 3. All you can do over here is rewrite this as f of 4. Then you say, okay, I'm calling on the function. So you have to go up here and look. And the thing I'm plugging into the function is a 4. And then you go over here and replace. In fact, some students, the x distracts them. So just think of it as a location. And whatever you plop in this location, you put everywhere else. So you put a 4 here. This is going to be 4 squared, negative 10. Negative 10, 4 squared, plus 50 times 4. And then you could calculate it. All right. But you can also plug in a variable. If I said, what is f of w? You would say negative 10 w squared plus 50w. If I said, what is f of broccoli stalk? You would say negative 10 broccoli stalk squared plus 50 broccoli stalk. It's that simple. It's just a location you plug in. Okay. So if somebody asks me, I'm going to erase this. And you can I have several practice sheets on this. But I wanted to make a video because it's just something that I see so many mistakes on. Okay. So if I wanted to study slopes on this thing, typically how we use this most commonly is we have this parabola. We're going to label this x. We're going to label this x plus h. I know this is more of a discussion for class, but I'm just going to say a couple things here. The height of this is f of x plus h. That's what the height when you plug in that thing, and the height here is f of x. So the slope is f of x plus h minus f. And this is the most important expression in calculus. It's where everything starts. It's called the difference quotient. But the act of writing it seems to bother people, and that's what this question's about. This question talks about average, and so it's asking about 4 seconds after it was thrown. So s of 4 minus s of 0 over 4 minus 0. So these are all kind of doing the same seconds. The next 4 seconds, so it's going to be from 8 to 4. So a lot of the questions in the homework are just asking you to plug numbers in and seeing if you can do it. These questions are asking you to plug in to this location. And a lot of students get that wrong, but that's part of why you get, I think there's 3 problems in a row where you practice this. Okay, so let's talk about this, and then we'll peek at that homework question. So what do we do? First off, you can't do this question. This question here doesn't make sense, this operation we're being asked to do, unless someone gives you a function. And we're going to use this function. So f of x is negative 10x squared plus 50x. So when you read this functional notation, you should call on the function twice. So the denominator is going to be h, because those x's cancel. The numerator, you're going to see the function twice. And this is, I can just at a quick glance see when students are off. So that's going to be the first time I call on the function. And then there's going to be a minus between them. Right now I'm right here. And then I'm going to call on the function again. And I did realize that I left off a square here and a square here. So the structure you can put together immediately. If someone gives you a function and the function is negative 10 times the input squared plus it, that's what this means. We called on the function appeared, We called on the function appeared. So without any work, I know what step 1 of this will look like. We will call on the function twice. So there's going to be a blank minus 8 blank squared. There's going to be a minus blank minus 8 blank squared over h. Sorry, make that a little clearer. So it's just a question of what they're asking you to plug in. In this case, they're asking me to plug in the first case, an x plus h here. In the second case, they're asking me to plug in an x. That's all functional notation is doing. So same here, we're going to put an x plus h here. And the second time, we're going to put in an x. There's a separate issue about simplifying, and that's its own challenge. Maybe I'll do that once here quickly, but I just want to talk about that first step. You should just see the function exactly the same, but with the input being x plus h. And then we'll go through and look at a few other ones. But it really should be that quick. So maybe let's grab one other homework question before I do the simplifying piece. So here's question 9 for my students this term. It has you do it in steps. I mean, because it doesn't think you can handle it in one step. But here it's calling on the function once. And so the whole function should appear with blanks in here. There's the whole function. You can see I put blanks where the x was. And now I'm going to replace that with x plus h. And then this expression would have that exact same thing. X plus h squared minus x plus h plus 2. And then I should see the function again right here. It's going to be 9x squared minus x plus 2. I know it's a lot of stuff, but you should be able to look at it and see the entire function is appearing twice, once with an x, once with an x plus h. The simplifying is a separate challenge, but the first step is not really a mathematical skill. It's just a following direction skill, which I guess is a math skill. But briefly, I have 3 bits, and we'll do this in class, 3 bits of advice here. It's a lot of simplifying the first few times you do this, but the key bits of advice is this will cancel, and this will cancel. So if this expression here does not completely cancel, and if the h does not completely cancel, then you've made a mistake. Okay, so those are important. That pretty much catches almost all errors. Okay, so here we go. The few challenges. So we're going to distribute this. We're going to distribute this. And then there's this piece we're going to have to learn how to expand. Some students know that already. Some need a little refresher. This is what x plus h squared means. Most students learn this as FOIL. I always call it monkey face. You got the nose, the mouth. But you're going to have an x squared. You're going to have 2 xh's. That's the nose and mouth. And then you're going to have an h squared. And that's just this piece. So then we have a negative 10 times that. And we have a 50x. And like I said, some students just say this is too much for them. But I think you can do it. You're not going to have to do it a ton this term, but it is the foundations that we build off of. And then we learn some shortcuts. So we're going to distribute the negative. That's all going to be divided by h. So I'm expecting everything that comes out of the second one to cancel. And I can see this already does. Okay, one last piece and I'll be there. And my math instructor always said, we're going to take a sad song and make it better. That's what we're doing here. This is going to simplify a whole bunch. I had another professor that called this wholesale cancellation. Okay, so that canceled, but I'm expecting this to cancel. It did. So if you make a mistake with your signs, then these things won't cancel, and then you'll know you've made that mistake. Now there should be an h in every single remaining term, which there is, and so you can divide an h out of each one. And then you can replace h with 0, and that's the velocity or the speed. So that we now have both things, the height of the ball, which was negative 10x squared plus 50x, and we have what's called the velocity. And it turns out if you want to answer questions like when is it at the peak, that's when the velocity is 0. If you wanted to ask how hard did I throw it, you plug in 0 to the velocity. Once you know the time when you're at the peak, you can plug it back into the height. So both of these things together are very useful when you're analyzing, when you're graphing. Calculus is the tool for analyzing a function. And so you will learn throughout the course of this term how to find that. But you got to be able to know a little bit of foundations, and that's what's happening here with the functional notation. Okay, so that's what we're computing, is that thing. It has major applications, so we're really finding this so-called tangent line. And it's fun to see this tangent line. We're at the peak, the slope is 0, and then the slope is negative, and we're going to study that throughout the course of this term, and any calculus class would do that. I thought it would finish with this. Here's an old exam question. This is from the last time I taught this course. And I can tell you about 60% of the class aced it, and then 40% did terrible on it. And I want to be 100%. I feel like everyone can do this. So I gave the students a function, 3x. I don't even think this is a math thing. I think the students that did poorly didn't prepare correctly, but I'm hoping I can get around that. So I give this function, and then I ask them to simplify this. So based off of the fact that students had done probably 5 or 6 of these in homework and studied, I thought more people would get it right. Anyways, step 1, you're going to have the function. And you should be able to see this when you do it. So there's the function. It's going to be called on once. And then it's going to be called on again. So I put the parentheses there to make sure that I'm subtracting everything that comes out of this from that. So then I'm going to have the 3 blank squared minus 4 all over h. And if someone who understands what they're doing, that should immediately be apparent, and they should have an x here and an x plus h here. And again, 60% of the class did that, no problem. But some people had that first step wrong, and I'm going to show you several examples here in a second. Then it was about simplifying. If you do it right, you know that everything out of this one's going to cancel. And so it's going to become 3, and this is something you'll practice a lot. Again, this isn't something we do all term. This is not what the course is every day. We learn several shortcuts, but there's this notation. Functional notation is something that is very important, and you will definitely use again in future courses. So this is where you would do a quick check. Did everything that came out of the second one cancel? Yes, 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 yes. If you didn't distribute the negative, you would have realized it didn't cancel, and then you would have gone back and fixed that. Students say, I made a bunch of silly math mistakes, and that's why I'm losing points. Everything here is checkable. So now you're down to this, and you know the h in the denominator should cancel. And so you get 6x plus 3h. Success. If you plug in 0, you get what we're going to call the derivative. This is 6x. And again, we're going to learn some shortcuts. Some students say, I know those shortcuts already. The shortcuts themselves do not tell you what the average is. So there's actually more information here than up here. So just even if you know a shortcut, you're not going to be able to answer that question and get full points unless you know that notation. Okay. So let's look at some of the mistakes. Students sort of nod their head and say, yeah, I can do it. And then they go and take the test, and this is what I saw. So see if you can spot the mistake here. What did this student do wrong? And you can see it right away. So when you write this out, you should see the function twice. All over h, and you should see an x here and an x plus h here. What did this student do? They put the plus h on the outside. And they lost almost all the points here. And I remember they came to me and were like, why did I lose all the points? Because this is what it's all about. So once they wrote that, what they were writing didn't even make any sense. Okay? Now they knew the derivative from some shortcut method, but they didn't know notation. So they lost those parts of the points. Okay, let's look at another one. I knew immediately there's something wrong here because the function should have been called upon twice. There's the function, but what's missing? You can see it. There's no 4 there. Somebody's like, oh, I just made a silly mistake, but it's something we got to be able to see. We got to practice this enough that we can see this. And that messed up what they were doing. Also, they should have realized this didn't cancel, so something went wrong. Oh, I have several more of these. Where did I put them? Let's look at another one. This is from an old test. Okay, what did they do? They should have had the function appearing twice, which they did. But notice that this -4 didn't cancel. So something went wrong. They didn't distribute. Everything that comes out of this should have canceled. So they should have caught that mistake. Okay, what about this one? They did this. Looks like they expanded incorrectly. They just called this, looks like some bad algebra here. They said that this was the same. They just multiplied this through. They did a really bad order of operations thing. So that's also a major error, but something else they should have caught because this didn't cancel. It looked like they just dropped it off. I don't know what's going on here. And then their H didn't cancel. So we should know something is wrong. And now the student said, well, I just don't know my simplification. But remember, that student had done like 5 or 6 of those in the homework 2 weeks before. So that's the thing I'm trying to remedy. I hope that none of this is meant to be negative. I just want you to see you can do well in this course. Everyone can do this. But you have to know the homework and know that the homework is going to be on the test. And so you have to, this is a skill that will be on exam 1. So you might as well learn it now. Okay. Hope you found that sort of interesting, even students that aren't in my class.